Okay, so how they actually measure atmospheric pressure is with a device called a barometer. So the details of how a barometer works is not really expected of you at this level in your chemistry career. But just so you know, it is called a barometer. So meter obviously means to measure, right? And then the baro portion means weight. So it's a measurement of the weight of air on the surface of the earth. So the first barometer, how they actually did this, is literally with liquid mercury. So this is actually where the millimeters of mercury unit began. It was the first unit of pressure that was ever recorded. So how this works is essentially there was a dish of mercury, and they took this small little narrow tube and they emptied the tube from with all the air. Like they basically sucked all the air out of it. So that's why this says vacuum. Like there's no air particles. And what happens is, imagine that there's molecules in the air. As they collide with the surface of the mercury, it forced or pushed up the mercury into the tube. So the more that the particles collided with the surface of the mercury, the higher and higher the mercury pushed up into the tube. So the standard pressure at 0 degrees Celsius, taken at sea level, literally measured 760 mercury millimeters high. So that's where that comes from. So obviously this is temperature dependent, right? Because if these particles are moving faster, there would be more pressure put on the surface. But also it depends on where you are measuring it in terms of altitude, like we discussed before. So I've already talked about this, but the atmospheric pressure is greatest closer to the surface of the Earth, and it gets further and further, the pressure lessens the further and further up you go into the atmosphere because there's more and more space between particles. So this is just obviously like a cartoon representation, but closest to the ground is where you have all of the air particles kind of tightly knit together. So there's a lot of collisions happening with the surface because there's a lot of particles here. As you go higher and higher, there's more and more space between particles. So the pressure lowers because there's just less and less collisions happening with the surface at the top of the mountain than there is at the surface at the bottom of the mountain. So this is also why if you, let's say, go for a hike at a very high altitude, you may find that you're not getting enough oxygen. Like you may feel really tired, like more so than normal. And that's because you're literally getting less oxygen. There is less oxygen up here in comparison to down here. Now, there are people who live at high altitudes around the world, right? So places like France, northern Italy, parts of Asia, right? So like lots of different mountainous ranges where people live and have survived for centuries. And that's actually because they have been evolved. They've essentially evolved or adapted to that environment. Even living things that are not people, like mountain goats, right? Mountain goats are able to survive at high altitudes with less oxygen. So they actually thrive in that environment, whereas me and you who grew up, in Toronto or in the GTA, and you try going up to, a very northern part of a mountain, may have a hard time living or breathing, or, if we try to go for like a little short jog, you get out of breath pretty quickly. So a lot of athletes who are going to be doing that sort of activity, right, they actually will have to train themselves ahead of time to get used to being in a lower oxygen environment if they had to go and do some sort of physical activity at higher altitudes than they're used to.